Hello everyone. I'm glad to welcome you to the next layer-by-layer vectorization lesson. Today, we will look at the topic, consider the example of compressor. During our next lessons, I recommend using the help function, F1 button, which will describe all commands and their parameters in more detail. To call it, you need to press the F1 button when using the command. You can also open the 3DScan tutorial using the Help 3DScan button on the Point Clouds tab in the Help group. Let's use the previously saved compressor file and continue with its example. Go to the Point Clouds tab and select the View Mode command in the Settings group. In the Coloring field, we can see that we do not have an option that can fully convey information about the object since the original file was presented in text format and did not contain metadata. In this case, I recommend switching to the 3DScan tab and using the Recalculation of Normals command in the Meshes group. Call the command, and the cursor will display options for applying parameters. Pay attention to the panel on the left, where we can specify the values of neighbor count and coherent adjustment numbers. The neighbor count parameter determines the number of neighboring points around a given point used to calculate the normal, while the coherent adjustment numbers parameter determines the number of neighboring points around a given point used to adjust the normal. Let's leave these values default and select the Yes option. Use the View Mode command again, and in the Coloring field, we can see a new Normal option, which should be selected. Here we have two options, half-space normals and normal as vectors. Check the box next to the half-space normals option. For more detailed information, you can use the help by pressing the F1 button. Also, set the point size to a value between 3 and 5, which will be needed when creating a UCS. Click OK. And now we need to create a UCS. To do this, go to the View tab, use the Coordinate System command in the Coordinates group, or press the Alt-U hotkey combination. Rotate the image by holding Shift and the middle mouse button, selecting points of the same color that correspond to identical normal vectors. Make slight adjustments by rotating the coordinate system around one of the axes, so that when viewing from the back, the side faces are parallel to the y-axis. After completing the preparatory work, switch to the 3DScan tab and select the Vectorization Parameters command. In this window on the left, we can see the recognition parameters. But first, use the Reinitialize section and its params command to set the section for vectorization along with the section width, which will influence the slice width parameter. Specify the section location as follows, and continue working with the parameters on the left. Initially, I recommend you to set the section width to 1/50th of the height of the point cloud. Let's intentionally set the section width greater than the height of the object itself. For example, 250. As a result, we will get an error. Setting an extremely small value will result in no recognition. Let's set the value to 4. Next, disable raster display using the Show Raster button located at the top of the viewing area. The result will vary from section to section as there is no precise section location. Next, choose polylines as the recognition result as the most versatile option and set the width value to 10. We can see that by capturing more points, the contour becomes smoother and many closed areas appear. In this case, it is the inner surface of the compressor. But such areas can also indicate topology distortion. Set the value to 7, and then proceed to configure the remaining parameters. The max edge parameter is responsible for the maximum length of the line to be analyzed when recognizing vector objects on the section. Lines longer than the maximum length will not be vectorized. In the far left position, more contours will be vectorized than in the far right position. In our case, it is sufficient to leave the slider in the middle position. The accuracy parameter is responsible for the precision with which vector objects should be recognized on the point cloud sections. This parameter directly depends on the quality of the point cloud and the selected section width value. Move the accuracy slider to a position where, when showing the raster, our vectorized contours match the raster overlay accurately enough. Click the Save button and close this dialog box. Next, select the Layer by Layer Vectorization command in the Features group. The command performs vectorization according to the data specified in the vectorization parameters. Before confirming, the panel on the left offers to change the previously set parameters. Set new ones. The coordinate system parameter determines in which plane the vectorization layers will move. When selecting the UCS value, the first section for vectorization will be taken along the XY plane of the current UCS, and then moved along the Z-axis with a certain step. Let's switch to the left view and set the view parameter. And in this case, the sections will be created one after another, starting from the plane of the current view in the direction of the gaze, and ending at the last point of the cloud. The output type parameter has three options: only vectors, raster and clip. When setting the value to only vectors, only vector primitives describing the section will be added to the drawing. With raster, in addition to vector primitives, raster images of the sections will be added to the drawing field. Raster and clip will add sections of the point cloud to the document, along with the vector primitives and raster images added to the drawing field. Let's choose only vectors. The step count parameter allows you to optionally set the calculation either by the number of steps or by the step size. We will leave the calculation at 10 passes. Click Yes. And observe the result of layer by layer vectorization, hiding the object. As a result, 10 layers of polylines are created. All objects are placed in corresponding layers with the name mask slice MN, where M is the number corresponding to the number of vectorization command runs in the current session, and N is the serial number of the section. Turn off all layers except slice 28.1. We see our section, and let's click on the hole for the bolted connection. They are recognized as closed polylines. If necessary, the object type can be changed to a circle. Turn off the Slice 28.1 layer and turn on the Slice 28.6 layer. In the Slice 28.6 layer, we see a section similar to the one on which we pre-configured layer by layer vectorization. This concludes our lesson and the main topic related to vectorization. In the next lesson, we will cover the functionality for recognizing pipelines when working with technical objects in the 3DScan program. Thank you for your attention. See you in the next lessons.